So this video is on the Activitiy Series. In your reference packet, you have an Activitiy Series of both halogens and metals, and it's listed in order from most reactive, easiest to oxidize, to least reactive, hardest to oxidize. A more reactive metal can replace the least reactive metal when it's combined in a compound. So take a look at your reference guide and find the page that looks like this. It's our page with our polyatomic ions. Okay, and we're going to worry about this Activitiy series, not so much the halogens, but really of the metals. Okay, on our Activitiy series of the metals here, we have metals towards the top, and then we have metals at the bottom. These metals will replace hydrogen from cold water. These will replace hydrogen from steam. These will replace hydrogen from acids, and these react with oxygen to form oxides. Okay. What we're really concerned about is the hierarchy of metals. These metals towards the top are the best ones. These metals at the bottom, we don't really want. Okay. If a metal is higher than another metal, the higher metal will replace the lower metal. So think of it as upgrading your phone. When the iPhone 4 came out, it was nice, but then the 5 came out. Do you want to switch the 5 for the 4? Why, yes you do. So then you upgrade. Then the iPhone 6 comes out, and that's up here. Do you want to upgrade to the 6 as opposed to the 5? Well, of course. So then you upgrade. Okay, you try to get to the top as best you can. And so this is our hierarchy, and this is the pattern we'll follow doing our reactions. So now we'll come to find that sometimes a reaction of a metal and then metal ions in a compound can't happen because that metal by itself is low on our list of metals. So let's take a look at some of our examples. Here we have lithium with copper 1 nitrate. Lithium and copper are two metals. If we look on our chart, we have lithium and then we have copper. Lithium is very high on the list, so lithium is going to bump out the copper. So lithium is going to now combine with our nitrate, and then copper is going to be by itself. The reverse, copper and lithium nitrate, well, copper is on the bottom. That lithium, or that nitrate, would rather have the lithium, the higher metal, than the copper one. So here we're going to have no reaction. Okay, it doesn't want the copper. It's too low on the Activitiy series. The next one, we have sodium with a solution of silver ions. We want to know if that sodium is going to replace the silver ions in solution. Silver down at the bottom, sodium at the top. The sodium would rather be in solution than the silver, so here, yes, a reaction would take place. The next one, we have the opposite, so here, no reaction. Go ahead and try our next one with aluminum and barium. Aluminum here, barium here. Would aluminum switch out with the barium? Yes, because barium is a higher compound. It's a higher metal on our Activitiy series. Then we have lead and magnesium. Well, here's magnesium. Lead's towards the bottom. That chloride would like to stay with his magnesium. This is our higher guy, so he's going to stay here. So here, no reaction. Because our chloride would rather stay with our magnesium because it's a higher metal a more important metal than our lead?